Do you remember how you first actually learned to count?
Oh, man. That's going way back.
Right. Or, well, better yet, do you remember that exact moment when the number 10 stopped being just a sound you made with your mouth and kind of, snapped into focus as this actual structural concept?
Like when it stopped being just a song you sang and became an actual rule.
Exactly, because we all walk around with this fundamental operating system for logic just installed in our brains, and we kind of assume it was always there.
Yeah, we totally take it for granted.
But someone had to teach you how to decode the world. So today we are doing a deep dive into a source that, honestly, it seems almost absurdly simple at first glance.
It really does.
It's literally a grade 1 math textbook called Learning Math for Grade 1, a first book of numbers, addition, subtraction, and shapes.
Which I know sounds a bit basic.
Yeah, but we aren't doing this to learn addition. We are doing this to basically reverse engineer the exact moment human beings are taught to perceive physical space, time, and like objective truth.
Right, because it is the ultimate exercise in stripping complex problem solving down to its barest psychological foundations.
I was genuinely shocked by how insightful it is for an adult mind.
It is. When you look at early math instruction through an adult lens,
Yeah.
it becomes so clear that we aren't just teaching rote counting. We are teaching, well, the psychology of noticing.
Noticing, yeah.
The text explicitly states really early on, math begins with noticing. It's basically a survival tool.
Wow, a survival tool.
Yeah, because it takes the overwhelming, chaotic noise of the physical world and gives a kid the structured mechanism to turn abstract concepts into visual physical realities.
And that transition from chaos to order, it starts with the whole philosophy of counting.
Mhm.
Because before a human brain can manipulate variables or do equations, it has to understand what a symbol actually represents in physical space, right?
Exactly.
So the book lays down this bedrock rule, one number to one thing, and it dictates that the final number you say is the total amount, which seems super intuitive to an adult.
Oh, sure.
But then the text introduces this massive cognitive hurdle. It completely separates how many from which one.
Ah, yes. Amount versus order.
Right. The book uses this garden analogy to show the drastic difference between picking 3 flowers, like a total volume of flowers, and just watering the third flower in a row.
Think about the cognitive processing power we are suddenly demanding from a 6-year-old there.
It's huge.
It really is. We are asking them to take the exact same visual symbol, the digit 3, and just, assign it completely different physical meanings based entirely on the syntax of the sentence.
Which is wild when you think about it.
Right. Because if the 3 represents a quantity, it's a volume of items you can literally hold in your hands. But if the 3 represents an order, it's no longer an object.
It's a place.
Exactly. It becomes a coordinate in physical space. And that is an enormous philosophical leap for a kid.
It is. I was actually trying to map this onto adult behavior, and it plays out like every single day in a coffee shop.
Oh, that's a good analogy.
Right. So if you walk up to the register and you order 3 coffees, you are establishing a quantity.
Mm-hmm. You expect a physical tray holding 3 cups.
Exactly. But standing in the pickup area, waiting for the barista to call out the 3rd coffee from their little docket, that is an entirely different state of reality.
You're just scanning a sequence for one specific item.
Yeah. And the language we use, like 3 and third, it's dangerously similar. To a child, those context clues are practically invisible. Why is that such a stumbling block?
Well, that abstraction is precisely where the system breaks down for young learners. They just don't have the mental scaffolding for it yet.
Right.
The textbook actually anticipates this roadblock and practically begs educators to bypass the abstract entirely. It advises drawing simple circles or lining up physical wooden blocks.
Making it real.
Exactly. It tells the child, if you're not sure, draw a picture. Because you simply cannot teach a spatial coordinate purely through auditory language.
You have to make the invisible concept of order totally visible on a table.
Yes. But then the book complicates this even further by introducing the necessity of a starting point.
Oh, right, the line of kids.
Yeah, it points out that the third child from the front of a line is an entirely different human being than the third child from the back.
Which basically introduces the concept of perspective into objective logic.
Exactly. Spatial reality is suddenly entirely dependent on your anchor point.
You have to establish where you are actually counting from, left, right, top, bottom.
Which naturally brings up, honestly, the most terrifying concept for an early mathematician.
The void.
The void, yes. What happens when you don't have an anchor point? or when you have absolutely nothing to count.
And I love how the book handles this. It introduces zero, not just as a blank space on the page, but as an active functioning number.
Right, it's not just nothing.
The example it uses is having two cookies, eating one, eating the other, and then holding a plate with zero cookies.
It frames zero as the presence of an absence.
Which is so deep for a 6-year-old.
It really is. Historically, zero was a concept that took ancient civilizations centuries of philosophical debate to formally invent.
Oh, wow.
Yeah, the Greeks and Romans really struggled with how nothing could somehow be something.
But this grade 1 textbook just casually installs this world-changing concept by telling a kid that none is still a quantifiable state you can manipulate.
Right, it acts as the ultimate placeholder. It literally holds the architecture of our base 10 number system together.
And that architecture is honestly what fascinated me the most, because once a learner understands amount versus order and they grasp the void of zero, they have to learn how to manipulate these symbols efficiently.
Right, moving from theory to practice.
Exactly. The text reveals that the magic key to all early calculation is the number 10. The book literally calls 10 a helpful stopping place or a friendly number.
A friendly number. I love that phrasing.
Right. And what's brilliant is how it handles the transition from single digits to double digits. It actively avoids treating numbers like 11, 12, and 13 as these new, terrifying vocabulary words.
Oh, like they're just completely unrelated sounds.
Exactly. Instead, it defines everything past 10 as just 10 and some more. So the number 13 isn't a random sound to memorize. Its structural reality is literally 10 and 3.
Which is genius because it drastically reduces the burden on working memory.
How so?
Well, if every number up to 100 is just a unique, disconnected sound you have to memorize, your brain quickly hits a capacity limit.
Right, you just get overwhelmed.
Exactly. By chunking the information into base 10, the textbook provides this scalable framework.
Okay, but I have to push back a little here because the strategy the book uses to enforce this method it calls making 10, it struck me as unnecessarily convoluted at first.
A lot of adults feel that way.
Right, because if you present an addition problem like 8 plus 5, the book actively discourages a child from just holding up their fingers and counting 9, 10, 11, 12, 13.
Yes, it wants them to manipulate the numbers instead.
Right, it forces them to look at the 8 and calculate how many more are needed to reach that friendly number 10.
Which is 2.
Yeah, so the child then has to mentally fracture the 5 into a 2 and a 3, assign the 2 to the 8 to build a 10, and finally add the leftover 3 to get 13.
Sounds like a lot of steps.
It feels like an exhausting amount of mental gymnastics just to avoid counting 5 fingers.
I totally get that. It looks like gymnastics if your only goal is getting the answer to 8 plus 5 as fast as possible.
Right.
But the objective of early math instruction is not to produce a biological calculator. The objective is to build a flexible mental architecture.
Okay, unpack that for me.
When you teach a child that a rigid integer like 5 can be fluidly shattered into a 2 and a 3 to serve a larger strategic purpose, you are teaching the foundations of algebraic thinking.
Oh, wow. I didn't think of it that way.
Yeah, you are basically teaching them that numbers are variables that can be manipulated. Because a teenager calculating complex algebra later in life won't be using their fingers.
No, definitely not.
They rely on that mental habit of finding the nearest base 10, fracturing numbers, and shifting the pieces around. Finger counting is basically a dead end.
So understanding that structural manipulation scales up infinitely.
Exactly. It shifts the focus entirely from just getting the answer to understanding the architecture.
And to really cement that architecture, the book leans heavily into framing math as a narrative. It literally says that a math problem is often a small story.
Yes, math is storytelling.
Addition is taught through these linguistic plot clues like altogether or gets more or joins. So the math is actually 3 candies and 2 more candies arriving on the scene.
A tiny little drama.
Right. And subtraction uses action verbs like eats, flies away, or comparing how many more. We are looking at these abstract symbols and turning them into physical plots with rising action and resolution.
Because it humanizes the cold logic of the numbers. Human brains are basically storytelling machines.
We really are.
We evolved to retain narratives way better than isolated facts. By wrapping an equation in a narrative, you bypass the brain's natural resistance to abstract data.
That makes so much sense. And this insistence on physical, tangible reality, it extends way beyond just addition and subtraction.
Oh, absolutely.
Because numbers are positioned not as these abstract entities floating in a void, but as the underlying code for measuring and organizing the physical world. And the rules for physical comparison in this textbook are brutal.
Brutal but necessary.
Frankly, it's a standard most adults fail to meet. The text outlines these strict physical laws for how you are allowed to compare objects.
Like lining up the ends.
Yes. If you're comparing the length of two pencils, the absolute rule is that you must line up the ends perfectly. If you are comparing the height of two block towers, you have to line up the bottoms.
Right.
The book explicitly forbids calling a short tower taller just because it happens to be sitting on a chair, while the physically taller tower is sitting on the floor.
Because the comparison lacks integrity.
Exactly.
You are observing a false differential caused by uneven starting conditions.
And think about the psychological weight of that rule if we actually applied it to adult life, to how we measure success.
Oh, that's a really profound way to look at it.
We constantly compare our careers, our relationships, our life milestones against other people without ever verifying the starting baseline.
We do. We look at our own tower sitting on the floor,
Mhm.
compare it to someone else's tower that's elevated on a chair of, like, generational wealth or lucky timing.
Right. And we judge ourselves as mathematically shorter.
When really we're completely ignoring the fundamental rule of grade 1 logic. Line up the bottoms first.
You cannot make an objective judgment without verifying a level playing field.
And the book actively trains the child to distrust their initial perception for this exact reason. It demonstrates how easily visual processing can be hijacked by optical illusions.
Oh, like with the blocks.
Yeah, it shows an illustration of 3 blocks spread really far apart on a table next to 5 blocks bunched tightly together.
And a quick glance tells the human eye that the 3 blocks are more because they dominate more spatial territory.
Exactly. Or it shows the classic illusion of pouring the exact same volume of water into a tall, thin cup versus a short, wide cup.
And your brain just screams that the tall cup holds more.
It does. But the textbook positions mathematics as the ultimate override for these biological optical illusions. Counting is objective truth. Visual perception is just a flawed guess.
And that pursuit of physical truth moves perfectly into how the book handles shapes, too. It doesn't dwell on just drawing 2D circles and squares on a piece of paper.
No, it makes it physical.
Right. It immediately forces the child to interact with 3D reality and physical function. It categorizes geometry by utility.
Like the box shapes and tube shapes.
Yeah. Box shapes have flat faces and stack easily. Tube shapes can stand upright or roll depending on their orientation. And ball shapes roll flawlessly, but are literally impossible to stack.
Which is brilliant because it isn't just teaching geometry, it is teaching physics and architectural limitations.
Totally.
That child truly understands the definition of a sphere only when they experience the actual frustration of trying to balance a wooden block on top of it and watching it fall.
The physical failure teaches the geometry.
Exactly. And that same pragmatic approach is used to demystify time and data.
Right, the clock.
Yeah, the clock isn't just this abstract circle. It's broken down into functional components. The short hand dictates the hour. The long hand handles the clock.
And it anchors that abstract measurement of time to the physical reality of a kid's day, like
Yeah.
waking up at 7 o'clock, lunch at 12.
Right. It applies that exact same pragmatic function to graphs and data, too.
I loved the section on graphs because it doesn't treat a graph like some boring corporate spreadsheet. It treats data visualization as a tool to clean up physical messes. Like if a kid is staring at a chaotic pile of mixed up red, blue, and yellow crayons, the cognitive load is just overwhelming.
It's too much visual noise.
Exactly. But by grouping them and creating a simple picture graph, that physical entropy is instantly organized. You can look at the graph and immediately identify the most, the fewest, or the same.
It is basically using data to reduce anxiety by imposing order on chaos.
Which is so deeply necessary.
It really is, because the act of learning these concepts naturally generates a ton of anxiety for kids.
Totally. And the textbook understands this psychological friction perfectly because at the end of the book, it actually synthesizes all these mechanical rules into a literal fairy tale.
Lina in the Forest of Addition.
Yes, it abandons the worksheets entirely just to illustrate the emotional journey of learning math.
It's such a clever shift in tone.
It is. So Lena's story begins with her feeling entirely defeated. She believes she's inherently bad at math, not because her answers are wrong, but because she isn't fast.
But she equates speed with intelligence.
Exactly. She watches her classmates shout out answers instantly, and she feels small. So she wanders into this glowing forest where she encounters animals struggling with practical, physical math problems.
The word problems come to life.
Yeah. First, she meets a rabbit holding 6 acorns, but the recipe for acorn cakes requires 10. So Lina kneels in the dirt, draws 10 empty circles, places the 6 acorns in them, and counts the 4 empty spaces to prove that 6 plus 4 equals 10.
Making 10.
Yes, and the forest tree magically rewards her with a glowing 10 acorn.
Notice the cognitive behavioral mechanics happening there, too. The abstract concept of finding the difference is physically mapped out in the dirt, and the resolution provides a tangible reward.
It continues with a sad frog who lost 3 of its 8 white stones in a pond. Lina crosses out circles in the dirt to demonstrate that 8 minus 3 leaves 5. The pond rewards her with a leftover stone.
Right.
Now, I have to admit, my initial reaction to this was a little skeptical.
Oh, really? How come?
Well, I wonder, does giving a kid a magical leftover stone just mask the cold, harsh reality of objective math? Are we just gamifying education to sort of coddle them?
I see why you'd think that. We are absolutely gamifying it, but not to coddle. We are hijacking the brain's dopamine loops.
Oh, interesting.
Because math anxiety physically triggers the amygdala, right? Which shuts down the prefrontal cortex where your logical processing actually happens.
So panic literally stops you from doing math.
Exactly. A child terrified of being wrong physically cannot access the part of their brain needed to solve the problem.
Wow.
So by turning abstract numbers into physical totems, like the 10 acorn, the book replaces the threat of a failing grade with the dopamine hit of collecting inventory in an adventure game.
That is so smart.
It lowers the effective filter so the logic can actually be processed.
Okay, that makes total sense. So she continues through the forest, helping a fox and a raccoon compare red and yellow leaves to find a difference of 3.
Which magically allows them to cross the bridge of difference.
Exactly. It reinforces everything we've discussed. Making 10, subtraction is taking away, and subtraction is comparing. But the real philosophical punch lands at the climax of the story.
The final problem door.
Yes. Lina reaches the store at the base of a giant tree, and after solving the required word problems, the door opens, but not to a treasure chest. It opens to a mirror.
A mirror.
Yeah, it shows a reflection of Lina sitting at her own school desk, looking curious rather than terrified. And the tree delivers the ultimate thesis of the forest. It says, math is not only answers. Math is looking, counting, putting together, taking away, and trying again.
It systematically dismantles the false metric of speed.
It really does.
Because the shapebird tells her earlier in the journey, understanding comes before speed. A seed doesn't rush to become a tree.
I love that.
The anxiety of being the first kid to shout the answer is a destructive illusion. What actually matters is the meticulous, slow process of understanding the narrative behind the numbers.
We have traced a massive cognitive journey today. I mean, we started by unpacking the profound difference between a physical amount and a spatial order. We looked at 0 not as empty air, but as a quantifiable void that anchors all of logic. We dissected why breaking numbers apart to reach that friendly number 10 builds the mental scaffolding required for algebra.
Right.
And we examined the ruthless physical laws of comparison, proving that you cannot judge 2 block towers without ensuring their bottoms are lined up on a level playing field.
And finally, through Lina's journey in the forest, we explored how mapping abstract concepts into physical narratives disables fear and unlocks real understanding.
Exactly. The through line connecting all of this is the book's foundational mantra. Math begins with noticing.
Yes.
It is not merely a subject to be tested on, it is a highly structured framework for perceiving reality.
Because it hands a human being the tools to cut through optical illusions, to organize entropic chaos into clean data, and to find verifiable truth in physical space.
And the introduction of this textbook offers a piece of advice meant to comfort a nervous 6-year-old staring at a worksheet. It says, mistakes are not the end. They are a place to try again.
Which is such a profound concept for adults to hear, too.
It really is.
I mean, think about how much adult anxiety stems from viewing mistakes as final judgments rather than simply a place to try again.
Oh, totally. We are so hard on ourselves.
We are. So what if we approached our complex adult problems with the exact same grace, patience, and simple visual mapping that we use to teach a first grader how to count to 10? Next time you are paralyzed by a massive, terrifying adult problem, like a failed project or a complex life decision, think about the baseline logic we use to teach human beings how to function.
We don't demand instant perfection.
Exactly. We demand a willingness to look, to count, and to map the variables in the dirt. Because the best way to decode reality isn't to rush to the finish line. It's to stop, look at the tower in front of you, and make sure you've lined up the bottoms.